Not the store, not the vault, but the beginning, where fire, sweat, and science meet beneath layers of rock. Every year, over $12 trillion worth of gold changes hands. But almost no one sees what it takes to create even a single ounce. To get here, gold must survive explosions deep underground. It must pass through acid baths, crusher machines, and furnaces hotter than lava. And behind every shining bar is a story of human hands, impossible odds, and relentless precision. Because gold is not just a metal. It's trust. It's survival. It's the quiet promise that something real still holds value in a world that moves too fast. So today, we're going on a journey. One that starts with dust, and ends with destiny. Let's begin. Somewhere beneath your feet, right now, lies a metal that built empires, ended wars, and still, to this day, holds the power to change lives. Gold. We've crossed oceans for it, fought battles in its name, and some gave their entire lives chasing its shine. Back in 1849, thousands of Americans packed up wagons, kissed their families goodbye, and headed west to California. They didn't know what they'd find, but they believed in gold. Not just its value, its promise, a better life, a fresh start. And that belief, it never really left us. Today, we don't pan for gold in rivers anymore. Now it's buried miles underground, locked inside mountains of solid rock, hidden in places so remote, machines have to be flown in. And still we dig, we drill, we endure, because even now, just 1 ounce can be worth over $2,000. But here's what most people never think about. What does it really take to bring gold from the depths of the earth to the palm of your hand? It's not just about metal. It's about labor, blood, precision. It's about stories buried as deep as the gold itself. And over the next few minutes, we're going to follow that journey, from the first explosion to the final shine, from raw stone to refined wealth, because the story of gold, that is really a story about us. Next up, we meet the people who risk their lives miles underground to find it. Ready to keep going? Before gold becomes beautiful, it is brutal. And the first chapter begins underground, where daylight disappears, and the only sounds the thrum of drills and the breathing of men who know the risks, but show up anyway. I want to introduce you to Mike. He's 58, a third-generation miner from Nevada. His hands are calloused, his voice quiet, but steady. He's spent over 30 years beneath the surface, chasing veins of rock that sparkle only under a flashlight. It's not about getting rich, he told me. It's about doing something real, something that lasts. To reach gold, Mike and his crew drill half a mile straight down, through layers of granite older than the dinosaurs. Then comes the blasting, controlled explosions that shake the earth and fracture the stone. Dust rises like smoke from the battlefield. Massive loaders scoop the debris into 40-ton trucks, crawling through narrow tunnels back to the surface. Each load, just maybe a few grams of gold, if they're lucky, and yet they keep going. The deeper they dig, the hotter it gets, sometimes over 120 degrees Fahrenheit. The air is thick, the silence heavy, and every step they take is a bet against time, rock falls, and machines that never sleep. But here's the thing. For Mike, and thousands like him, this isn't just work. It's legacy. It's the pride of knowing that something they touch will one day sit in a wedding ring, a bank vault, or maybe even a medal worn on the Olympic stage. They'll never see the final shine. But without them, gold doesn't happen. And as we leave the mine and return to the surface, we're not just carrying rocks. We're carrying the beginning of a transformation, a journey that's only just begun. Coming up next, what happens when rock becomes powder and chemistry takes over? The rock comes out of the mine looking ordinary, gray, jagged, heavy, but inside, there might be millions of dollars locked away in particles so small you'd miss them even with a magnifying glass. So what do? We crush it. Every load of rock goes into towering mills that roar like thunder. Steel balls the size of grapefruits grind the stone down, spinning day and night. And what comes out isn't gold. Not yet. It's mud. A thick, soupy slurry that looks more like wet concrete than treasure. But inside that gray mixture are tiny flecks of gold, invisible to the eye, but precious beyond words. At this stage, it's no longer about shovels and trucks. It's about chemistry, gravity, precision, patience. The slurry flows through a series of tanks and filters. Sometimes, it passes over shaking tables where heavier particles, like gold, settle to the bottom. Other times, it's treated with a cyanide solution that dissolves gold like sugar in hot tea. Sounds dangerous? It is, which is why everything is sealed, monitored, and handled by technicians who know exactly what they're doing. Then comes the moment of truth. Activated carbon. Think of it like a super sponge. It is added to the mix. It grabs onto the dissolved gold, trapping it molecule by molecule. And suddenly we're no longer chasing rocks. We're chasing dust that's starting to become something more. But here's what's wild. After tons of crushing, mixing, and filtering, all we get is a thick, black sludge, just a few pounds of it. That sludge, it's called gold concentrate, and it's worth more than its weight in platinum. It doesn't shine yet. It doesn't sparkle. But this humble, sticky mass is about to begin its next transformation. Next up, how fire chemistry and centuries of technique turn sludge into molten gold. You can't see it. You can't hear it. But right now, $1 billion transformation is happening inside a tank of dark gray sludge. And it all comes down to trust. Trust in chemistry, trust in people, and trust in a process that turns muddy waste into pure gold. Here's how it works. That black concentrate from earlier, it's pumped into massive tanks, sealed tight, no room for error. Technicians carefully add cyanide, a chemical powerful enough to dissolve gold at the molecular level. Then comes oxygen, bubbling through like soda fizz. Together, they break the bond between gold and rock, setting each particle free. It's silent, it's unseen, but in that moment, gold begins to let go. From here, the solution passes through columns filled with activated carbon, granules so porous they can absorb the gold atoms directly from the liquid. Every drop is precious. Every second matters. In this stage, there's no flash, no glow, just data. Sensors monitor temperature, pressure, flow rate. Technicians take hourly samples, adjusting chemical levels down to the decimal. Because even a 0.1% mistake can cost thousands of dollars. And here's something few people know. The men and women who run this part of the process, they're not just engineers. They're guardians, protecting millions in value with nothing but quiet concentration and a deep respect for their craft. They don't wear gold watches. They wear lab coats. But they're the reason gold exists in the form we know it. By the end of this step, what's left is called gold sludge. It doesn't sparkle. It doesn't shine. But inside that sludge is something priceless. Certainty. Certainty that what once looked like waste is now worth everything. Next up, we leave the lab behind and enter the fire, where gold is reborn in molten form. Everything so far has been building to this. The crushing, the chemicals, the long nights in the lab. And now it's time for fire. In a high-security room lined with brick and steel, the sludge collected from the refinery is dried, pressed, and prepared for what comes next. Smelting. Massive furnaces roar to life, heating the mix to over 1,000 degrees Celsius, hot enough to melt stone, let alone gold. It's not quick, it's not gentle, but it's necessary, because this is the moment gold begins to reveal itself. As the sludge melts, impurities like silver, copper, and iron rise to the surface, forming a dark, brittle layer called slag. Operators skim it off slowly, like foam from a boiling pot, revealing the glowing, molten gold beneath. And for the first time, it shines. Not like jewelry, not yet, but like liquid fire, flowing with weight, light, and purpose. Technicians pour the molten metal into cast iron molds, each one shaped to precise dimensions, each step timed down to the second. The room is silent as the molds are filled, not out of fear, out of respect, because everyone in that room knows this is no longer just ore. This is wealth in its most ancient and purest form. The bars cool slowly, changing from glowing orange to rich, matte gold. They're still rough, still impure, about 90% gold, with traces of other metals. But they have a name now: door bars. The first physical proof that all the dust, danger, and data was worth it. Each bar is weighed, stamped, logged, tracked like royalty. They are not yet perfect, but they are ready for the final transformation. Next up, how we turn a 90% gold bar into 99.99% perfection. The answer lies in acid, electricity, and absolute precision. The door bar is heavy, solid, golden, but don't let its glow fool you. It's only about 90% pure, and in the world of gold, almost isn't good enough. So the bar's journey continues into a place few ever see, the final refinery. Here, fire gives way to chemistry and electricity, and every gram is treated like a sacred responsibility. First, the door is melted again and dissolved in a powerful acid bath, typically a mix of nitric and hydrochloric acid, known as aqua regia. This isn't just science, it's ancient alchemy, perfected over centuries. In the solution, gold separates from everything else. Silver, copper, nickel, all stripped away with careful control. Then comes electrolysis. An electric current is passed through the solution, causing pure gold atoms to leave the liquid and attach themselves to thin metal plates, called cathodes. Bit by bit, layer by layer, the gold reforms. No longer hidden, no longer mixed. Now, it's nearly 99.99% pure. That number isn't just marketing. It's measured, verified, and guaranteed. Technicians monitor every variable: voltage, chemical concentration, temperature, with military precision, because even the tiniest fluctuation can ruin an entire batch. These labs don't feel like factories. They feel like operating rooms. Quiet, sterile, focused, because in here, mistakes are measured in millions. And when the refining is complete, the gold is melted one last time to ensure perfect uniformity, then poured into molds again, each bar shaped to exact international standards. It cools slowly, carefully, and when it's done, it's no longer door. It's bullion, the highest standard, the global benchmark, recognized by banks, government, and industries around the world. Next up, how does that pure bar become the gold you see in vaults, tech, and wedding rings? Let's step into the final stage, casting and quality control. It's pure now, tested, verified, trusted, but gold isn't finished until it's formed. So here at the final stage, everything slows down. No rush, no noise, just heat, care, and absolute precision. Large industrial furnaces hold the molten gold at exactly the right temperature, hot enough to flow like honey, but cool enough to preserve its perfect chemistry. Then, technicians add fluxes, special compounds that absorb any last traces of impurities. It's a final cleansing, a quiet ritual before the cast. And then, with steady hands, they pour. Molten gold fills the molds. Some designed for standard investment bars, others for custom ingots, coins, or even industrial applications. Every mold is preheated, measured, and inspected to prevent even the tiniest imperfection. Because at this level, even a micro crack can be $1 million flaw. The gold cools slowly, under strict control, to prevent stress or weakness. The metal shrinks as it solidifies, pulling tightly into form. Then the molds are opened, and there it is, a bar of gold, smooth, solid, nearly flawless. Each one is now weighed, measured, and laser inscribed with its purity, weight, and refinery code. These markings are like a passport, ensuring authenticity, traceability, and global acceptance. No two bars are exactly alike, but every single one must meet international standards before it can leave the refinery floor. This is where industrial science meets timeless wealth. From here, the bars will be stored in vaults, shipped to central banks, or crafted into the jewelry and technology that powers the modern world. But no matter where they go, each bar carries within it years of work, layers of labor, and the quiet dignity of those who never touch the spotlight. but built the gold inside it. Next up, why does gold still matter in today's digital, fast-moving world? And what does each bar really represent beyond its price tag? Hold a bar of gold in your hand, and it feels heavy. But what you're really holding isn't just metal. You're holding history, sacrifice, trust. Gold has no battery, no code, no digital footprint. And yet, governments, banks, and billions of people around the world still measure value against it. Why? Because gold never fails. In times of war, economies collapse, but gold endures. Currencies rise and fall, but gold holds its ground. Technology changes by the day, but gold stays pure, consistent, and timeless. It conducts electricity with unmatched precision. It resists corrosion in the harshest environments, like space, or inside your heart in a medical device. And when markets panic, investors run to gold. Not apps, not coins, gold. Because gold doesn't just represent money. It represents stability. It represents proof that something real still holds meaning in a world built on promises. And maybe most importantly, gold is human. Every bar began as dust, touched by miners, guided by chemists, poured by hands that may never be seen. Yet without them, there is no vault, no wealth, no shine. So the next time you see gold, on a finger in a bank or behind bulletproof glass, remember what it took to get there. Mountains moved, fires lit, lives spent, all for something that, through every age, through every storm, has never lost its glow, and maybe never will. Your turn. Backhand index pointing right. Which part of the journey surprised you the most? Tell us in the comments below. And if you enjoyed this deep dive, don't forget to like, share, and subscribe to Mega Factory for more stories that reveal the extraordinary behind the ordinary. Up next, we leave the mind behind and enter the world of microchips. From grains of sand to the brains of every smart device on Earth,